Okay, till now we have discussed about the lot of Hadoop ecosystem tools. We have discussed about the HDFS, MapReduce, Hive, Pig, Scoop, Flume, Uzi, Zookeeper. So these are the all Hadoop ecosystem tools. So Hadoop mainly we will use for the analyzing the data. If you want to do any analytics or analysis, if you want to analyze the data, we will use the Hadoop ecosystem tools. So we will load the large volumes of data and we will analyze the data. So for that Hadoop tools we are using. Coming to under big data, we'll have one of the main main concept called NoSQL. So what is this NoSQL is simply not only structured query language. So from past few years, 1 or 2 years, so this NoSQL is getting very popular. Previously uh, from 10 years or 15 years, we have the RDMS is the only databases we are using for the all the purposes. So Oracle, MySQL, we are using for the all use cases, and we have used previously. But from past 1 or 2 years, so these NoSQL databases are getting very popular, and recent data and the whatever the data we are getting recently from past few years, so RDMS is not fit for the all the use cases. So that's why they introduced the NoSQL. So why the RDMS is not fit for NoSQL, we'll see the next upcoming slides. I will give some examples. So what is the limitations in the RDF? So why we are going to NoSQL, I will show you. So coming to the NoSQL, so NoSQL is simply not only structured query language. So that means, so we can store the schemaless data and we can store the unstructured data also we can store. So that is the concept NoSQL. So the NoSQL is having a lot of advantages. So upcoming slides I will give more details. So coming to database type, limitations at the DMS side, what is the limitations? So generally, if you take any web applications, we have the RDMS called RDMS will have a backend for storing the data for any application, and we'll have the different web applications or web or servers, uh, web servers or application servers will be there, and we'll have the clients for accessing the web servers or the application servers. So here multiple users can access, and web application tier or server tier, we can have the multiple applications, multiple web servers or application servers for scaling the applications. So these two okay, but coming to relational database, so RDMS, so most of the applications or servers we will read and write handling. So read and write request will handle by the single RDMS. So if we want to store the gigabytes and more 100 GB data, 200 GB data, so we need to pay a lot of cost. We need to suppose if you take the RDMS or any one of the databases, we need to pay a lot of money. So if the data is growing, we need to pay a lot of money. And application performance, suppose if you are having the lot of read and write requests, so the performance will be automatically it will goes down. So that is the, suppose if the database is having facing any network problems or hardware problems, so then we can't able to access the RDMS, and there is a chance of the particular web server or application down. Maybe there is a chance of application down. So this is the limitations about the relation database. So only one database is there. So if we having the, if you want to store the more databases, and if it is handled to more write and request access, and if there is any problems at the network side and the hardware side, so then it's very difficult to maintain the RDMS. So these are the limitations at the normal databases types. So these are the application side, we can get the system cost and application performance. But coming to RDMS side, so if you want to store the more data, it is very cost to maintain the server, and Application performance also, more data, for more data it will be it will goes down. Uh, Automatically the performance will be down. So that is about the limitation about the database type. Coming to NoSQL at the database type, so we can like the different web application server scaling. So we can scale at the database type also, we can scale. So we can provide the distributed data source. So we can database style also, we can provide distributed data store. So we can store the data in the different machines. So here more request or more reader write request is there. Some of the machines will take care about the reads, some of the machines will take care about the writes. So we'll share the load. So then if we are having a lot of more data like terabytes and more than that data also, this NoSQL databases will handle. So here, so most of the NoSQL databases are the open source. So the cost of the if you want to store the more large of the data, large volumes of data, so the cost also will be less, and performance also will be, if you want to handle the more data also, the performance also will be the same, like if for handling the gigabytes and terabytes of data, it will be similarly it will be there. So so if you want to, if you are getting more data, we will involve the more machines. So then the performance we can maintain, same performance we can maintain for the handling the large volumes of data also we can maintain. So compared to the previous two things, so the whatever we have discussed in RDMS, so compared to this one, the cost also less and performance also it won't be goes down when the data is more data we want to serve for the read and write request. So that is about the database type, NoSQL at the database type. So we can scale the uh, we can store the data in the distributed fashion in the NoSQL databases. That is one of the main advantage about the database type. So why uh, the NoSQL came into picture. So what are the different challenges with the traditional databases? So normal RDMS databases or traditional databases are not good fit for the large data volume, petabytes of data, and with varying data types. So if you want to store the different kinds of images, videos and text and different kinds of XML, the JSON data. So if you want to store the different documents data like JSON, so it is not good fit for the storing the different varieties of data and large volumes of data, and can scale for the large data volume. So if you want to store the petabytes of data, for example, the other project data, so it is not scale for the uh, large volumes of data. I think other project they are using the HBase or the MongoDB they are using for the other project. So we can use RDMS for that purposes. So it is the schema based. So generally the RDMS databases are the schema based, means fixed columns while creating the table, difficult for adding the more columns for existing tables. So this is the one of the main feature, main limitation in the RDMS. So suppose if I store the 1 million records with the suppose if I have a table with 10 columns and I have stored the so if I have a table with the 10 columns and I have stored the 1 million records, so after storing the 1 million records, if I want to add the one more column, it is very difficult for adding. So I want, so then I need to uh, place the all the existing records as a null, and then I need to create one more column, and then I need to, for new records, I need to store the data into new columns. Suppose if I want to add the different columns, So then it is very difficult to schema based. So in recent whatever the data and whatever the use cases are there, so we are not having the data as a same columns. So we are for the record to record and for the for in real-time data, so there is no similarity, and there is a lot of difference for the record to record. We are not having the similar kind of fields, so that's why only the schema database is not fit. Suppose for example, uh, suppose the Facebook or the any one of the social media data. So if you take the if you take entering the data as a, in social media, generally for creating the account we need to fill the different kinds of details. We need to fill the personal details, education details, job details, and any other details. Generally we need to fill the different details in the forms. But if you take the data of the different users, so previously, well, what kind of data we are storing? So we will store the databases in the employees data, and suppose any website related data, and we will store. So mostly the data, it will be similar structure, it will be there. So uh, coming to this real-time data, so we don't have the similar kinds of people. So some people will be uneducated people will be there. Some people will be educated people. Maybe students will be there. Some people will be job holders will be there. So if you compare these different peoples, so we don't need to fill all the details for the all the users. Suppose if you take any a user with uneducated, so then they don't need to fill the all the other education and job details. They only need the only personal related columns. So for the for his case, for his case, so he don't needs the other columns, so all the other columns needs to be put the null. So if you maintain the fixed kind of schema, suppose if you go to the educated like student case, so if he is purchasing his 10th or intermediate, so they don't need to fill all the other UG and PG details. So in that cases, you don't need the other details like UG and PG columns and the job details. So like this, the suppose if the job holder case, so he will fill the all the personal details, education details. If he worked in different 4 or 5 companies, he needs to fill the details in the 4 or 5 columns. So if you observe these details, so lot of difference is there in the different users data. So we are not in real time data. We don't have the fixed kind of columns kind of information. So for the person to person, for record to record, we will a lot of data variance will be there. So one person, if you have the some columns, other persons don't need of the that columns. So in that cases, this fixed schema based columns are databases are not suitable for these use cases. For that, they are using the some other uh, 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 these databases, NoSQL databases, they are using for this purpose. So if we use the NoSQL databases, we can store the data as a different schemaless tables we can create, and we can maintain the different columns for the different users. So that is the one of the advantages of NoSQL and limitations in the RDMS. So schema based means, so we will fix the columns while creating the tables. Difficulty for adding the different columns for the existing tables. So one column it will be okay, but each person to person, so there is a lot of data variance and different kinds of data if you want to store. So then the schema based databases are not good fit. And also scale up, so limited by memory and CPU capabilities for the databases. And sorting causes operation problems, example managing a short failure. So sorting means partition. If you want to partitioning the data, it will be very difficult in RDMS. And consistency also bottleneck for scalability in RDMS. So these are the different limitations in the traditional databases. Main things are handling the large volumes of data, and if you want to handle the real-time use cases or real-time scenarios, suppose if I want to maintain the n number of columns. Suppose if I want to, if there is a chance of maintaining 1,000 columns, it is very difficult in the RDMS. But in NoSQL, it is possible, and uh, it will be we won't face much problems for handling the multiple more columns. If you want to maintain 1,000 columns, 10,000 columns for the table, you won't get any performance issues in the NoSQL databases. So, but we will face a lot of problems in the RDMS databases. And why NoSQL? So these are the different features in the NoSQL: flexible schema, distributed. So data we can store as a distributed fashion, horizontal scalability, non-relational, and we can provide the replications for the avoid the data failures, and open source. So most of the NoSQL databases are open source. Some of the databases may have the enterprise versions. So for that we need to purchase license. But most of the databases will are the open sources databases. So these are the different NoSQL database categories are there. We will have the different databases. So key value store databases, column oriented databases, document oriented databases, and graph oriented databases. So coming to key value store databases, so entire the data it will be stored as the key value stores. So they will have the, if you have worked, previously if you have worked on hash maps, so similarly they will maintain the key value base of data. So this is very fast kind of accessing and writing and reading databases. So some of the companies are using this key value stores databases, like Amazon Web Service are using Amazon DynamoDB. So I will show some what are the different kinds of databases in the next slide for the each kind of databases. So I think we have the plenty of the NoSQL databases. I think more than 100 NoSQL databases are there. So that will be different companies are creating different NoSQL databases, and they are using the different NoSQL databases. So in those all the NoSQL databases, some of the NoSQL databases are getting very popular, and market also some of the databases are using having lot of popular and lot of demand in the market. So in those HBase is related to Hadoop ecosystem tool and Hadoop family. This one of the databases in the Hadoop ecosystem tool are HBase. So HBases are getting very popular, and Cassandra. So it will be both HBase and Cassandra are the NoSQL column-oriented databases. So HBase is related to Hadoop. So Cassandra, it will have own kind of architecture and own kind of things. It will be there in Cassandra. We won't store the data as a HDFS in the Cassandra, but whatever the data we will store in HBase, internally it will store into HDFS. But apart from the HBase, all other databases it will have own data structures internally. And if you want to use the any one of the column-oriented database and Hadoop family, we can go for the HBase. And if you want to separately, if you want to build the NoSQL database, then we can go for the Cassandra. And we'll have some different uses are there. So some of the limitations in the HBase is there. Some of the limitations in the Cassandra will be there. Based on our use cases, suppose if you want to get more reads, then we'll go for the HBase. If you want to have, if you need the more writes, then we'll go for the Cassandra. So based on the different use cases, we'll go for the different databases. So these two databases are popular in the column-oriented HBase and Cassandra. Coming to MongoDB, coming to document-oriented databases. So MongoDB, one of the popular databases, and most of the companies also started working on the MongoDB. So Java developers also, instead of the MySQL and the Oracle, they are trying to connect to MongoDB, and they're storing the database data into MongoDB. So I will show some examples, column oriented, how the columns data it will be stored, and document how it will be data it will be stored. I will show you. And CouchDB also getting very popular recently. So that will be based on the different use cases and business needs. They are going for the different databases. These two are column and document. Coming to graph databases, so generally if you have any connected data like friends relation or friends relations, like that, if you are having any relations kind of data, connected data is there. So this graph oriented database are we can very popular. And in this graph oriented, Neo4j is the very popular one in the graph oriented database. So coming to key value means will entire data it will store as a key value base. So Amazon DynamoDB is one of the popular databases, and Redis, and we'll have the some of the key value base, and these things are Redis and Amazon DynamoDB is the popular databases. But till now I didn't see the real use cases of the key value base, but some of the companies are using this key value data stores are using. So those also key value data stores also very popular, and some of the companies are using. And Neo4j graph databases, Neo4j is very popular databases. Column-oriented HBase and Cassandra is popular databases. And coming to document-oriented databases, so MongoDB is very popular, getting very popular. So what is the NoSQL? Where will use these NoSQL databases? So we will use this NoSQL database in Facebook chat messages. So if you take the chat messages, so we need to store the lot of data. So every day we'll get a lot of data. RDMS, it is very difficult to maintain with the RDMS databases. So that's why we are going the kind of Facebook chat messages, user notifications, and graph search. We'll go for this NoSQL databases. So these are the different use cases: messages, charts, emails, and SMS. So for this kind of internally for this kind of applications, for any user notifications, suppose we'll have the lot of users in the any Facebook or the any online shopping. If we take lot of users are there, for that they will daily they will get the notifications. So this kind of notifications also the NoSQL databases, and the so this kind of count also getting the counts. So this also the NoSQL databases are the, like how many friends are there, how many messages, how many notifications are there. So this kind of all these things, this NoSQL is the best use cases. And also user notifications as the Flipkart. So online shopping also it is notifications also they are using. So graph search. So coming to graph search, if you go to Facebook top right, so we'll have this kind of search. So for this also they are using graph search, graph databases. If you want to search the friends of friends, relations, kind of connected data, if you want to search, so this graph search is very popular. So generally, why we will go for this graph databases? Suppose if we have the connected data, we need to store the different data in different tables, and we need to perform the lot of joins. Suppose if I have the millions and the billions of records on each table, if I want to perform the 5 joins or more than suppose if I have the 10 tables of data, and each table having the billions of records, if I want to provide the relations between these tables, suppose if I have the suppose if I want to maintain the relations between these amounts of data between the different tables, so that is very difficult, and it will take a lot of time to performing the joins operations on the large volumes of records. Suppose if you have the more billions of records and if you want to perform the joins on the 10 tables, it is very difficult to perform the joins. It will take a lot of time. For avoiding that, so for getting for that limitations, they are using the graph databases. If you have the connected databases, so directly we can make the whatever the records if you want to perform the joins. So by using the graph databases, we can easily perform the such. So within seconds, if you have the large volumes of data, also billions of records, also within seconds we'll get the this kind of such we'll get such results we'll get. So I will show the how the graph databases it will be there. I will show you. So other big data technologies, this part I will cover in the upcoming classes. I will cover. So generally, any one of the databases they will follow the CAP theorem. So CAP theorem means mainly it will be concentrating on the consistency, availability, and partition tolerance. So most of the databases will provide any one of these two requirements. They will satisfy. Third requirements third requirements also it is try to satisfy, but it won't satisfy that much. These any one of the databases will satisfy the any one of the two requirements. It will satisfy mostly. So if coming to RDMS, mostly it will provide the consistency, availability, but some part of these two it will provide. But coming to some of the databases, it will provide the CP means consistency and partition tolerance. So this MongoDB, HBase, and Redis, some of the database will provide these two, consistency and partition tolerance. And coming to some of the Cassandra, these will provide the availability and partition tolerance. So what is consistency means? Suppose if I write the data to the one machine, generally the NoSQL we are telling as a different data will be stored to a distributed fashion. So consistency means suppose if I write the data to the one node, so same data within seconds I can able to retrieve from the other nodes also. I need to retrieve. So if I try to connect to another machine in the database, I need to get the same data from that machine or particular machine. I need to get the data. So that concept is called consistency. So whatever the data I have written, immediately I need to get from the other nodes also. That is consistency. Availability means suppose if I have the any failures, so data won't be the entire cluster won't be down. So we need to provide the availability. So that is availability means data failures also we need to without the service loss. So we need to provide the data. So that is data availability. And coming to partition tolerance means so we generally we will in NoSQL we will store the data as a different machine. So that is means we'll distribute the data. That is called partition tolerance means. So if you face any network issues also, if one partition is failed, so without this partition loss, so we can if there is a chance of the partition to, failure, so we need to avoid that one also. Partition failures also we need to avoid. So that is the partition tolerance means. So we need to prepare with the partition failures also. If any partition is failed, we won't lose the data. So that is called partition tolerance. So these three features will provide consistency, availability, and partition tolerance. We need to generally the CAP theorem will tells about the consistency, availability, and part tolerance. So some of the databases will provide the consistency and partition tolerance. Some of the databases will provide the availability and partition tolerance. So based on the requirements, so based on the use cases, so we'll go for the any one of the databases. Suppose if we want more consistency, fault tolerance, we'll go for the any one of the these NoSQL databases. And if you want to get the more available than partition tolerance, then we'll go for the these Cassandra, DB, any one of these databases will go. So these are the some points about the CAP theorem, and theoretically it is impossible to fulfill all three requirements. So any one of these things it will provide. Some of the it will provide consistency and availability, and most of the RDMS will provide this consistency and availability. So the data it will be stored in single availability. And coming to CP, so consistency, partition tolerance, some of the NoSQL databases will provide, and availability and partition tolerance, some of the database it will provide the AP. So this is the one of the popular theorem for the databases. So consistency, availability, and this is the theoretical concept. So most of the databases will follow this theorem. So these are the some of the why you go for the NoSQL, some of the points. And generally the NoSQL databases will follow the base, not the ACID. So I think most of the RDMS will follow this ACID concepts. So, but the NoSQL database will follow the base, means basically available, soft state, and eventually consistent. So these terms, these things, it will follow the NoSQL databases. So these are the these things we already discussed: flexible schema, distributed, horizontal scalability, and these are the some of the key values to some of the points of the key value stores. So it will be based on the data model. It will be like a collection of key value pairs. Example, DynamoDB and some other databases are there. So the data it will be stored as a key value pairs in the key value stores. And coming to big data clones or the column-oriented databases, so mostly the column-oriented databases will follow the big table. So big table is the Google concept. So based on this big table clones on big table papers only, they have introduced the column-oriented databases. So the column-oriented databases, so it will have the data, it will be stored as a column families. So some of the columns maybe we can kept as empty. So we can maintain only some columns for the some records. So that is about the column-oriented databases. We'll have the HBase and Cassandra, the popular column-oriented databases. Coming to document-oriented databases, so in document-oriented databases, we can store the data as a JSON data we can store, and we can store the other data also, different kinds of documents we can store the data. So the internally it will have the collection of key value pairs only. It will be pointed to some records will be a name like name and value and ID and value, like a collection of key value collections it will be there. I will show the example for the document database how it will be there. And examples are the CouchDB and MongoDB. Coming to graph databases, so the graph databases will have the different nodes, relations, and the properties. Will have the different kinds of things in the graph databases. And example databases are the will have the Vertex DB and Neo4j. Neo4j is the popular databases. These are the some of the databases. And coming to this is the example for the document data. So anyway, I will show one presentation is there for the particular all the different kinds of data. We'll have the I will show the what is the difference between the RDMS tables and document type. So generally the document will be the documented data will be like this. Instead of storing the data as a different tables, the document data it will be stored. Similarly, instead of storing the different kinds of table data, we will store as a like this. The document JSON data it will be there. Point here, one more point is Hadoop, whatever the tools, Hadoop ecosystem tools we have seen till now. So those tools we can use for the OLTP or OLAP application. So we can perform the single row insertions and single row updations in the ecosystem tool. So we don't have the any storage kind of single row insertion and single row updations we can provide through Hadoop ecosystem. Hadoop ecosystem tools, what we'll do means, suppose if we have the data, bulk amount of data, we can load it and we can perform the operations in the Hadoop ecosystem tool. So through Hadoop we can analyze the data. But if you want to store the data, we can store the, by using whatever the tools we have discussed till now, we can store the data for the backend of the applications and the transaction data we can't use. But in Hadoop ecosystem tools, we have the one database called HBase. So that is related to column-oriented databases. So in that databases, it will support for the OLTP and OLAP applications. So we need to use for the, based on the need only, we need to go for the that HBase. Generally, if any one of the applications we are able to handle through RDMS, we can go for the RDMS. Suppose if you have only, if you have the structured kind of data, fixed column, and data also we have only gigabytes of data, then we can go for the RDMS. Whenever we need the, we have the large volumes of data if you want to store, and we'll have the schemaless kind of use cases are there, then only we'll go for the this other NoSQL databases we need to use. So coming to, I will show the different kinds of RDMS and the NoSQL databases. I will show you how the generally will store the data. I will show you. Generally, the RDMS tables will have the data will have like a different tables will have, and if you want to fetch the data, I will have the some primary key or foreign key. It will be there. So and I will generally the data will be shown in the different tables, and if I want to get the data from the different tables, I will provide the joins and I will get the data. So if I want to add one more column here, it will be difficult in the RDMS databases. Suppose if you have the data with the millions and billions of columns, and if I want to perform the join operations, it will take a lot of operations for the join. So because of these limitations only, we are going for the NoSQL databases. Instead of storing the data as a different tables, we'll see the how the different column databases, how the data will be stored. We'll see. In column-oriented databases, generally the data it will be stored as a different column families. Suppose instead of storing the data as a different tables, so the entire table it will be data it will be stored as a different column families. So column families means, so it will have the group of columns it will have, so that will call as a column family. So in most of the column-oriented databases, while creating the tables, we will specify the column families only. Under this column families, we can store the different kinds of columns. We can dynamically we can create the columns. So while creating the table, we won't fix the columns. We only fix the column families. Under this column family, we can based on the need, we can dynamically we can adjust the column. Suppose if you want to add new column, we can add it. If we don't want the column storage itself, we can provide the storage for the particular column. So here if you observe, so first record I need the all the rows I need. First record I need the all the columns. Coming to another record, I don't want the some of the generally, suppose if I don't have the birth date, then I can simply storage itself. I can keep it as I won't provide any storage for this birth date. So this is just for example. In real time, the data it will be like this only. So they don't need about the birth date. So whatever the details it is there, we will enter. Suppose if you take any social media, so in that cases, there is no necessity of filling all the education details and job details. If you want, you can fill it. So otherwise, there is no need of filling the other details. But what they will do is backend they won't provide the storage for that column. Simply they will skip those columns for the particular records. Whoever didn't enter the records, whoever are not interested to filling the data. So for in that purpose I'm telling so this column if I want I can skip in the thing, and if I want to add one more column for the this one, so I can add. So like this, if I want to skip this gender, I can skip, and if I want to add one more column here, for the particular row, I can add the data for the that column. I can provide. So that is about the this column family. So by using this column family, we can here I'm showing only the skipping the column, but if you want, suppose if you have the one more column family for the personal data, like any one of the married or the marriage status, so then for this row itself I can create column, I can specify the column name and I can store the values. So how we can store the particular row for the particular column and value, I will show while explaining the HBase. So generally there is a possibility for a single row. If I want to store data in for a particular only single column, it is possible. Simply I will specify the what is the column family, what is the row ID, and what is the name, what is the column name and column value. So simply specifying that one, I can store the data. I can insert the data, and remaining columns, if I want, I will skip. So storage side also they won't provide the any storage allocation for the particular column. So this is about the column oriented database. So generally the data it will be stored as a column families. So while creating the table, we won't fix the columns in the column oriented databases. Instead of that one, we will specify the column families. If you want to add one more column family after creating the table and after storing a lot of data, if you want, we can add the one more column family. We can add it, no problem. So suppose if you are pointing to that column family and if you point into particular column, if you don't have the data, simply it will display as a null. So we won't get any errors. Suppose if you are trying to access one of the column which does not exist data for the any one of the record, so then it will simply shows as a null. So that is the advantage of the this column oriented databases. So while creating the tables, we won't specify or we won't fix the column names or columns. What are the columns are there? We won't fix it. Okay, this is about the column oriented databases. So we'll show the data as a column, different column families. Inside the column families, we can maintain the different columns we can maintain. So this is the by using this one we can schema we can create the schemaless tables. So while explaining the HBase, you will get more clarity how we can store the data as a column families columns. I will show you. HBase I will show you how we can store the database into HBase. And coming to document oriented tables, so generally the data it will be stored as RDMS whatever we are storing. So we will store as this record we will store it. So instead of ID, first name, last name, so we will store as like this. The document directly we can store as this document directly we can store into database, and each document so they will have the one unique ID. So in that unique ID for getting the data we'll have the some unique ID. So in that they will have the data like ID, last name, first name, zip, city, state. So like this we'll have the data as a single record we can maintain. So instead of maintaining the more tables, so we can maintain as if the data is like documentary, we can maintain. So generally the JSON documents will be like this only, it will be there. So same example, if you have the more tables, so we can complex document data will be like this. We can maintain the sub key value pairs we can maintain. So one key will contain the multiple key value pairs internally it will maintain. So like this, whatever the data, suppose if you have the geolocation kind of data, you can maintain as a coordinates and types you can maintain, and description also we can maintain like this, and file and length we can maintain. So whatever the data if you want to maintain, so we can maintain like this. So instead of maintaining the data in different tables, you can maintain as a single record. So this is how we can store the data. Please go ahead.
Yeah. No, this document data will have any kind of schema or DTD attached.
Schema for the JSON data, they won't attach any schema. So here, suppose one record having all these ID and schema, username, geolocation. So some of the next record they don't have they can contain the ID, schema, timestamp, and username. So they don't have the other record. So like that also we can store the data. While retrieving the particular this geolocation, simply we'll get the null value.
Okay.
There is no schema for the each record, so we can scalable for the one record. We can store the different kinds of columns, and some records we can store the some of the columns we can skip it.
Okay.
That kind of things we can do in document data. So coming to graph-oriented databases, so generally the tables data it will be stored as a nodes, and if you are having any relations, we'll store as a this relations will store as a relations. So suppose one kind of suppose if you have any person is there, so that persons can contains the different kinds of properties can contains. So that properties will be different for the one person to another person. Suppose the person is related to related to job holder, they can contain the different fields. Suppose if any one of the person is related to business kind of person is there, they can maintain the some other properties. So that like that we can maintain the different kinds of properties for the different kind of users. And if you want to provide the relations like friends, so here we can find the have, organize. So that kind of relations we can maintain. So graph contains, so graph data will contains the different kinds of nodes, relationships, and each node will contain the different kinds of properties. So generally the data internally it will store as like this nodes, and they will maintain the relations. So when we'll go for the graph databases means, suppose if you have the lot of connected data, so if you want to maintain the lot of relations, so generally the RDMS for the perform the joins, so it will take lot of time. But this graph databases, simply from which record to which record, if you want to maintain the relations, simply we will traverse through that graph. So that will be, it will be very easy. So in graph we have the lot of graph algorithms internally for finding the easy path, and so because of that one, that facility, so we can easily find the relations, and within seconds we'll fetch the data. Suppose if you have the lot of nodes and lot of records of data, so then also we can easily fetch the data by using this graph search. So we can easily fetch the data. So this is one more example about the RDMS tables and the graph nodes, RDMS tables and graph nodes. So generally, if you have the data in different tables, so generally we need to perform the join operations, and we need to get the data. So like suppose if you have billions of data, so it will take a lot of time to perform the join operation for getting the data. But here if you take simply, if you have the more data, large volumes of data also, simply we will find the, we will search the path for the whatever the nodes we want. So simply we will search for that records and we'll fetch the records. So this is very easy to, instead of joining the all the records and fetching the records. So simply whatever the records we want, so we will go for the particular records and we'll fetch the data. So this is very efficient, and within seconds we'll fetch the data. So generally the Facebook will use this kind of graph search, and Facebook are using the giraffe for the graph search. So they are using the graph models only. So this is about the graph databases. So these are the different use cases. So based on our business use cases and project use cases, they will use for the different databases. I will from tomorrow, not tomorrow, next class, I will explain the HBase. Then I will try to show the how the MongoDB and how NoSQL databases and how the environments it will be there. I will try to show the MongoDB and Neo4j, and HBase is related to Hadoop ecosystem tools. So then I will cover most of the topics in the HBase, and I will show the how we can execute practically, how we can create the column. I will show, you'll go through the HBase and MongoDB and Neo4j also previously I worked. So I have the environments. So I will show how the MongoDB database it will be there and graph database it will be there. Neo4j I will show you. And this is all about the NoSQL databases. This is the basic introduction or the basic overview only. But whenever you are starting working on the different use cases, then only will get the more need. What is the need of the these databases? So these databases are getting very popular recent days because of different advantages, distributed and schemaless. So these databases are getting popular. So if you are getting more experience on these databases, then only we'll know the what is the power of these databases and what is the real use of these databases. We will know. So these databases are getting day by day. They are introducing the performance kind of improvements and they're using. So if you are following these databases articles, then only you will get more details. So this is the basic introduction. What is the NoSQL and why are the NoSQL database are getting popular? Different kinds of databases. So tomorrow next class we will go for the this HBase. What is HBase? And I will go through the architecture of the HBase and how we can store the column families, columns. I will go through the this HBase. So thank you all.